So this is Observability with Spring, and this is a very, very dense talk. And the goal here is basically giving you some basic concepts and also some summary, and also a ton of buzzwords that you can Google later on. So there is some homework. I'm Jonathan. I work in the Spring engineering team. I work mostly on Micrometer, also on Spring Cloud Sleuth. I will talk about those later. And also I work on a thing called Spring Observability. And other than this, I am one of the leaders of the Seattle Java user group. You can find my Twitter handle, and you can read my blog. This is our safe harbor statement. This only means don't believe me ever. And today what we are talking about is what observability really is, why do we need it, the 3 pillars of it. You might have heard about that. It's kind of a buzzword. That's one thing that you can Google. Also how to implement it using Spring. And then my favorite part of this talk is the non-conventional components of observability, because there are a whole other universe other than these. And we will have some Q&A at the end. So let's get started with these questions. So this is a definition from Wikipedia, and this is a picture I took from people reading this definition. So let's try to summarize it or come up with something more compact. So observability really is about how well we can understand our system. It can be software, it can be anything else, or the internals of that system based on the outputs that it provides. So the system needs to provide meaningful outputs, and meaningful is key here. It's not just garbage. It needs to mean something. So it provides meaningful information for you, and you should be able to know or have some idea about what is going on inside. So this also has a couple of consequences. For example, you need to be able to ask arbitrary questions if your system is observable, without knowing ahead what you want to ask later. And this is a very tall order. This means dealing with unknown unknowns. That's a hard problem to tackle. Also, it should turn data points and contexts into insights, and you should be able to quickly troubleshoot issues with no prior knowledge whatsoever about the system. And this is very hard to do, also about unknown unknowns. And why do we need it? So in one word, I would say complexity. We live in the cloud era. If you have heard about the Death Star architecture or big ball of mud, if you haven't, just look at the pictures. Every single point on these 3 pictures is one server or service. And the edge between them, the line between them, is they are talking to each other. And these pictures are, as far as I know, they are all over the internet, so maybe I'm lying. This is the don't believe me part, if you remember. The first one is Amazon, then Netflix, then Twitter, 10 plus years ago. Right now, if you think about it, this is way multiple magnitude worse. So we need to deal with this complexity. We are not dealing with our LAMP stack, like an Apache web server with PHP and MySQL. Don't tell to Josh Lang that I'm talking about PHP. Because that was kind of simple. You had just one server, maybe 2. You ran your application there. You had a couple of components, they talk to each other. That was way easier to troubleshoot that we have right now. So because of this, because we live in the cloud era, we need to face unknown unknowns. We might not know where our application live or run. We might not know how many instances do we have, or what versions, in which environments. And we cannot really attach a debugger to them. And we cannot debug them usually just runtime. So also there is a crazy thing here. On this scale, if you have a huge scale for your applications, something will always broken. This is because of the law of big numbers. So I really like this analogy in the last line, which is observability is sending rovers to Mars, because after you launch it, you cannot really modify it or do anything with it. It's gone. So if you need to like figure out something, you need to troubleshoot, you need to fix something, you only have those built-in things that you put before launch there. Also, these environments can be chaotic, and trust me, they are. So you turn it up here, and like 2 regions later, somewhere else, maybe days later or weeks later, I have seen like months later, services go down. Also, we cannot really know everything. We need to deal with these unknown unknowns. And I'm not sure if you have heard this, but I have heard this a lot. People are saying, hey, this should be impossible, or that will never happen. And somehow, once, maybe weeks, months, or years later, that thing actually happened. I have seen this in a stack trace. The error message saying, hey, this should never happen. And it was there. Also, the same thing can be perceived differently from different point of views. So maybe if you are looking to your service, everything is good. It's healthy, it works, perfect. But maybe everything is down from the perspective of the user. Also, if you want to improve something, it's usually a good idea to measure it first. And the most common things that you can like measure and improve, usually people are going with resource utilization, CPU memory, I/O. You can like easily measure these, and not so easily, but sometimes you can improve those. Also like throughput, latency. But there are like other things as well that you can like look like after these. For example, how frequently do you deploy? Or how long does it take the code to go live? Is it like a minute, 2, 5, a week? I've worked for companies where the deployment was like at least a week. Because it started on Monday, it always needed to be Monday, creating a ticket for the ops team, organizing a meeting for the ops team, so that you were able to deploy on the next Monday. You can measure and improve these, and that is kind of falls the umbrella under observability. Also, how long does it take to troubleshoot an issue or recover from an outage? Or how often are you paged? I have seen people on this very conference getting paged while they were listening on talks. I have a friend who works at a big company. I'm not saying which one, but when she's on call, like dealing with a page, it took her like 1.5 to 2 hours. And she's getting on average 6 pages per day. That's well over 8 hours. If you want to improve that, you need to measure those things. Also, another thing Observability can do very well, it can open the door for very, very advanced capabilities. For example, chaos engineering. Don't do chaos engineering without observability. Chaos engineering, by the way, it's just like intentional failure injection. Or you can do anomaly detection when you want to detect like something is out of trend or something is fishy. You can also use it to support and implement feature flagging. So you can turn features on and off on a schedule or manually or based on like whatever you want. A/B testing comes like very nicely with observability. They go hand in hand, or basically all of those. A/B testing should answer the question if like, hey, is this better or is that better? For example, like, will users click this button more if this button is green than it is like blue? Also auto-tuning. I guess like Chris Stellinger talked about this a lot years ago. Auto-tuning is basically an act when you have a running application and you change parameters, runtime, and you are also observing that app. And you are checking if those parameters makes your app performing better. It's like, it can be like a generic algorithm that is constantly running, and it is basically like makes your app more and more performing. You can also use it for adaptive applications that can grow and shrink automatically, defend themselves. They can automatically fail over, recover some from failure based on the environment. So let's dive into the 3 pillars, which is the most popular approach, and I need to emphasize this, and I cannot emphasize this enough. This is not the only approach. You can get these like dimensions out of your system by using these, but there are other solutions. I am not going to talk about those today because this is the most popular one. I am going to talk about this. So the 3 pillars are basically logging, metrics, and distributed tracing. And the logging is basically here for answer the question, hey, what happened? And it is doing it by emitting events. You saw these, I am pretty sure about that. And it is these events are easy to read and grab. Please don't do this in production. Like use a logic ingestion system, never SSH to prod, and grab your logs. Use something which is for this problem space. And yeah, these are the usually like info warn, error level events. If you're unlucky, stack traces as well. Metrics, on the other hand, they should answer the question of, hey, what is the context of this? And it is doing it by measuring and combining the data. So metrics are always aggregatable. And metrics can be used to identify trends, and they are not very traffic sensitive. So for metrics, sending the same request like 2 times or 2 billion times should not make any difference. It's not the case for logging and distributed tracing. And distributed tracing is here to answer the question why something happened. And it is doing it by recording events with causal ordering. And it can identify the cause, like what caused this, throughout like threads, processes, or like network. Like that's why it is called distributed tracing. You have distributed applications and you want to know what event caused what. And it is doing it via context propagation. I will talk about that later. But first, let me give you an example for all of these, or actually 2 of them. One of them is when you want to know something about the latency of your application. So in this case, logging can look like, hey, processing this request took like 140 milliseconds. But is this bad? Or is this good? We don't know. We don't know. We have 0 idea about the context at this point. So that's where metrics came to the picture, and they can say that, hey, like 99.999% of the requests were faster than this. And the max is 150. So this is quite bad. It's definitely not good. But why was this so slow? We don't know. So that's where distributed tracing came to the rescue. And it can tell you the topology about your call. Like it can say that, hey, this is what happened. Service A called service B, and service B called the database. And the services was okay. The network was okay. And the database was slow. And in some cases, it can also tell you that, hey, the database was slow because you requested too much data. So don't do it and everything will be okay. Another example can be like you get an error. So your logging can look like, hey, request processing failed. Here is your stack trace in your face. But was this bad? Yeah, it failed. So it's definitely not good. But how many of them failed? What is the blast radius? We don't know at this point. What is the context of it? So in this case, metrics can tell you that, hey, the error rate was 0.001% or like per second. And we had only 2 errors recently. So it's not that bad. Maybe you can live with that. It depends. If this was your $1 million transaction, maybe it's not good. But the blast radius is definitely not big or doesn't seem big. It depends on your throughput. But why did this happen? Don't know. So distributed tracing, again, it can tell you the topology of the call. And it can say, hey, everything was okay, but the database failed. And why did this fail? Sometimes it can answer it that as well. So in this example, it can say that, hey, there was an invalid input. The service did not validate it because why would it do? But the database did. So it failed. Let's dive a little bit into each of these. So let's start with logging. The first type of logging that you, or logs that you can see is like application logging. I believe most of you are familiar with that. These are the debug info warn level events with some stack trace. But you can also have like payload logs. And with payload logs, you can basically report or like save somewhere the raw request and response pairs. And this is very, very useful if you, for example, want to reproduce something. Because trust me, 99% of the time when your client reports an error, they will say, hey, this failed. What? and why? So being able to track this down is a huge plus. Also, there are GC logs. It's a JVM feature. I'm not going to talk about that a lot. You can use it to troubleshoot and improve your GC performance. Also, there are access logs, which are logs from the underlying HTTP server, for example, Tomcat. I know Tomcat is technically not an HTTP server, it's a servlet container, but it has an HTTP server component which does the access logging. Also, you can do other things like audit logs. From security perspective, they are vital. Or you can, I am not saying you should do it, but you can put metrics and traces as well into logs, if you really want to. Or if you want to see what is happening under the hood. But don't do this in production, that's not good. Okay, so if you want log from a Java application, if you want to do some logging from a Java application, you might use SLF4j. I will talk about that in a couple of slides. So you can get your loggers from a logger factory. You just say that, hey, this is the level of the log entry, and this is my log message, or this is what happened. You can also attach an exception and so on. And this is what you can see in the bottom line. There is a timestamp, the level, who did that, and what was this. So you can read this easily. Access logs, on the other hand, they should give you automatically some details about the HTTP request. So you will see the timestamp, you will see some details about the request, some details about the response, and you can extend it for a while, but you will not see everything. For example, you will not see the request body. So this is an example for payload logs. Again, you will see some details about the HTTP request, and you can see the headers. This was a GET request. It doesn't have any body. GET, by the way, can have a body. This one did not have. But this is the response, and the body is there. So this can be very, very useful if you want to see the real thing, what happened over the wire. And this is not only for incoming requests and the response that you send back. If you are using an HTTP client and you have support for that, you can see the outgoing request as well and the response that you get back to. This is an example for GC logs. It will tell you what happened under the hood, GC-wise. And if you want to implement logging using Spring, I have good news. Spring Boot comes with SLF4j and Logback pre-configured. So SLF4j stands for Simple Logging Facade for Java, and it's a simple API for various logging frameworks. You can just plug them in and out. They have adapters and binders, or the logging library can basically implement SLF4j natively. And Logback is one of them. It's a modern approach to do logging using mostly with SLF4j, and that's what Spring uses under the hood, Spring Boot. You can replace Logback to Log4j if you want. It is by just excluding a dependency and getting a new one. It's not very hard. Okay, you can have payload logs as well. Spring Boot does not support it out of the box, but there is a project called Logbook. And Logbook has Spring Boot support. And they have a Spring Boot starter project, which will basically auto-configure everything for you. So you will have the same user experience. Get the jar, set some properties if you want, and bang, you will get payload logs out of the box. You can turn access logs on and off. Spring Boot does support for them. It has support for all of the servlet containers that Boot supports, which is Tomcat, Cherry, and Undertow. It's just one flag. You can just turn it on. Also, there is a project called Logback Access. You can funnel your access logs to Logback as well if you want, because by default, the if you are logging through your like servlet containers, they will emit the logs on their own. So this will give you some kind of like a common ground for all of your logs if you use Logback access, but you don't need to if you don't want. Also GC logs, like Spring doesn't have support for that because that's a JVM feature, so you just turn like JVM args in and you're good. Cool, let's talk about metrics. Just very, very shortly. By the way, like each these green slides I am showing, that could be a separate talk. So that's why this talk is quite dense. But if you want to hear more about this, after this talk, just like tell us in the feedback form. And maybe the organizers will like let me to do like a one-day workshop out of this with live coding. Okay, so Metrics 101. Metrics is basically about time series data. And time series data is basically data that can change over time. You have a data point, and 5 seconds later you have another data point, another one, and so on. If you want to plot this, then this basically means that you have a value on the y-axis and you have time on the x. It can be used, as I said, to identify trends, context. You can like detect anomaly. It is extremely good for visualization and for alerting as well. There are like various metrics backends that you can use. I will show a couple in a couple of slides, and they can work like very, very differently. For example, some of the backends you need to push the data towards. Some of them will pull you. For example, Prometheus. And there are like other things. For example, Dimensionality. I am not going deep in that, but if you go to the Micrometer docs, you can read about that later. So this is an example for a time series. In the first line, that is the name of the time series. You can see that this is the count for the incoming HTTP requests. And in the last line, the number, like 2.0, that is the value of it. And what is in between, those are called tags. And the tags can identify these time series. And if you have like different set of tags, that will be another time series. So if you have something like this, and you can see that, hey, this was a request which was coming in, we have two like this, and all of them was a get, and all of them ended up being 200. If some of them was like passed, you will have another time series. If some of them was 404, you will have another one. And you can have like a cardinality explosion here, so be careful about that. But just don't put user data or something that can grow infinitely, and you will be okay. Just very, very shortly, a couple of like types of meters that you can use to record metrics. There are way more, and like other systems are like calling these like different names and handle them differently. But the previous one was the counter. So you can use a counter, for example, to record the rate of something or the frequency of a change. If you are a math person, that's the first derivative over time. You can use it, for example, to count the incoming rate of HTTP requests, or like cache hits and misses. How many cache hits do you have per second, or how many misses do you have? The other type that you can use, and it is like one of the basic types, is a gauge. Gauge is basically showing you a value, a current value of something. For example, the CPU temperature over time, or queue size, or whatever, like a room temperature. There are many, many use cases here. And this third one, it is interesting because this is where things can get fuzzy based on which metrics library are you using. But there are timers, distribution summaries, distributions, summaries, histograms, and so on. Other people call them differently, but the point that these are usually composite metrics. So when you record, for example, with a timer, you are recording some latency, you will not just get that, hey, this happened, or the histogram of it, but you can get a count, a sum, the max value of it, maybe the min as well. That's a little bit harder, but you can get that out too. If you optionally, you can get a histogram or percentiles. And the same thing with distribution summary as well. You can get the distribution of something, like the distribution of the incoming or outgoing like bytes on the wire. So if you want to implement metrics using Spring, then we have good news. We have Micrometer, which is the most popular metrics library in the JVM. And we usually say that it is like SLF4J, but for metrics, because it has a simple API and it supports most of the most popular metrics backends. So Spring Boot comes with this. If you have like Spring Boot Actuator, I have good news. You already have Micrometer for free. Spring projects are instrumented with Micrometer, and there are a lot of other like third-party libraries that are instrumenting themselves using Micrometer. And when we say like SLF4J but for metrics, this is what we mean. These are the backends that we support, and I'm not sure if it was released, but there should be one more. So maybe this slide is outdated. It depends if Tommy, my colleague, who is the lead of Micrometer, has like pushed this and released it out. But it should be like one more in May. Okay, let's talk about distributed tracing in a little bit deeper sense. So the problem here with distributed tracing is, let's say that we have this topology. So there is a browser calling your service 1. Service 1 does 2 calls for service 2 and 3. They are calling their own database. How can you track this? How can you track when somebody called your first service and what happened later? How can you basically like group these events together and say that, hey, these belong together? How can you identify calls? How can you answer questions like, why did this happen? So distributed tracing does something interesting with this. So when there is a incoming request, it will basically ID it. And this ID called a trace ID. So when this happens, and let's say the ID is 1, 2, 3, when like this service does something, everything that belongs to this request will be ID'd with this. And if the service calls out to something else, to another process, or over the network, this ID will travel on the wire. So the next service, when it will like get the request, it will say that, hey, I already have an ID. So everything I am doing, which belongs to this, or triggered by this request, that will be ID'd with this. And there are two terms we should discuss here, span and trace. So span is basically a basic unit of work. It's an operation that you can like identify somehow. And the trace is basically multiple spans, like they belong together. And what can be a span? For example, a DB call. So this is a span that's identified with IDE. The other DB call can be also a span, of course. Service 1 calling service 2 can be a span. Service 1 calling service 3 also a span. You can say that, hey, I am doing two things. Let me wrap these two things into one span. You can do that too. And also when service 1 called, this whole thing is that belongs to a span. So you can see that it is kind of telescopic. So something happened which is like it is nested. Like something else happened triggered by that and so on. So you can basically like imagine this like a tree-like structure. So we have these like span IDs and trace IDs, which can identify the spans and the traces. And we can also have a parent span ID that we usually have on spans. And the parent ID is good for identifying this parent-child relationship. So you know which span belongs to which one, or which span triggered this one. They can also contain like timestamps, other events. You can attach like arbitrary tags. These are just key value pairs. The process ID, if this is a network code, and the remote IP, and also the local IP address. And you can use this or this information for log correlation and visualization as well, which I am going to show you here. So if you have, let's say, like two services, service A and service B. Service A is on the top, B is on the bottom, and they are emitting these log events. So service A got a request, it's processed it, and throughout the processing of this request, it called out to service B. Service B got this request, validated it, called out the database, did whatever, sent the response back. So when this happens, if this happens a lot, like you have like millions of these per second, or minute, whatever. So if it is like a lot, then you will not be able to identify which belongs to which one. So that's why we usually write the trace ID and the span ID to logs. So the first number between the timestamp and the level, that's the trace ID. That's the same for all of those log events. That's how you know that, hey, all of these belong together. And the second number, it's the span ID. That's how you know there are two spans, because there are like two different span IDs here. And it is not there, but the parent span ID can also be there. So span 3, on the bottom, they can say that, hey, the parent of this is 2, which is the previous one. And also, you can visualize this. So this is OpenZipkin, and this is like this can give you like a trace view. It's also like a backend that can like store your spans. And what you can see here is, it is nice and color-coded. So what you can see here is T-service was calling water service. And water service was calling the water database. And also, T-service was calling T-leaf service, and T-leaf service called the T-leaf database. So that is basically the like breakdown of your like service calls. And you can also get a timeline. So you can see that the whole thing, it's like in T-service. And that whole call consists about basically two big parts, calling the water service and calling the T-service, the T-leaf service, sorry. And you can also tell that those calls did not happen in parallel. Those were sequential. Because if they would be parallel, those two lines, like in the raw of water service and in the raw of T-leaf service, they would be like under each other. They are not. They happened like serially. Also, you can see like other things, like the tags I talked about, like the key value pairs. You can attach any metadata that you want. And usually instrumentations do attach those. Okay, if you want to implement this using Spring, we have good news. We have Spring Cloud Sleuth. And Spring Cloud Sleuth is the distributed tracing support as of today for Spring. And it provides a abstraction layer on top of like different tracing libraries. Today we support Brave, which is from the OpenZipkin community. And this is the default. If you just use Sleuth, you will use Brave under the hood. And we are also supporting OpenTelemetry. The OpenTelemetry support is experimental because OpenTelemetry hasn't released the stable version yet. Hopefully they will, and after this happens, then we will also release the support for OTel. It also does log correlation for you. So if you put Sleuth onto the class path, you will see the trace ID and the span ID in the logs automatically. And also does context propagation for you. So when your service, and you are using, let's say, a supported HTTP client, when your service is calling out to another one, the trace ID and span ID will automatically travel over the wire and go to the next call, or sorry, the next service. Or if you are using like supported things like Kafka, RabbitMQ, whatsoever, those are also instrumented by Sleuth. So it doesn't need to be HTTP. If you are like sending an AMQP message, for example, with Rabbit, in the headers, you will see the trace ID and the span ID because of Sleuth. Spring projects are instrumented by Sleuth, and you can instrument your own applications as well. There are instrumentations for third-party libraries throughout these tracing libraries like Brave and OTel, and we have support for various backends because of those. And this is a interesting slide because this is what will happen hopefully soon. What we are doing right now is we are moving Sleuth into a project called Micrometer Tracing. So Micrometer will stop being just a metric library. It will be kind of like a observability library, if I can say that. So Sleuth will be discontinued if you are going with Spring Boot 3, Spring 6, and the matching version of Spring Cloud. Sleuth will not be there. But Micrometer Tracing will be there, and the code base is the same. So we just moved those like code base over, change the package name, and that's all. So you need to change your jar, and you need to change the package names, your imports, if you are already using Sleuth. If you haven't, then it will be just Micrometer tracing for you. And the thing that we want to add is the observation API. And this is a really neat thing. If you want to implement these 3 pillars of observability, and you want to instrument your code, and you will add a timer so that you can record metrics, and you will create spans because you want distributed tracing as well, you need to instrument your code twice. So what the observation API does, it tries to give you a tool set so that you can instrument your API only once. So you can start an observation. I am observing a thread sleep, but you can observe anything. You can signal that, hey, an error happened while I was processing this. You can stop this observation. You can attach tags, which are not here. And you can do other things as well. Check the docs. We would like this to be a very, very easy thing to use so that your life will be easier when you want to implement observability. And this is just emitting events, starting and stopping something. So what we are doing under the hood or in the background, you can define your set of handlers, and you can register them. And once you do this, those handlers can be notified when these events happening. So your handler will be notified that, hey, somebody started an observation. These are the details. Or somebody stopped that observation, or an error happened, and so on. So we are providing out-of-the-box handlers for you. So by just doing this, you should get metrics and distributed tracing out of the box. And that should come with Spring Boot 3. And also, we would like to move this and instrument the whole Spring portfolio using this API. Okay, cool. My favorite part, non-conventional things. So the question really here is there anything beyond this? So just to go back 40 slides back in time to our definition about observability, we are looking for something that provides some output for you, which is meaningful and tells you something about what's going on inside of your system. One example can be Spring Boot Actuator. By the way, this is my favorite Spring project. And Spring Boot Actuator does a lot of things. I believe majority of the people are familiar with its endpoints. For example, the env endpoint can be very, very useful. It can give you all of the configuration details that you have. It doesn't matter what source they were coming from. So you can see how your service was configured. Or the health endpoint, which can tell you is your service healthy or not. You can also use it to register your Kubernetes aliveness and readiness probes to this, because you can organize them into groups. So you can decide which one do you want. The info endpoint, which I will talk about a little bit more in a couple of slides. The loggers endpoint, that's pretty neat. You can change the log levels of every logger that you have. So if something happened and you don't know what is going on, you can just basically go to this endpoint, and without restarting your service, you can change the log level for, I don't know, a couple of seconds, a couple of minutes until you see that event happening, change it back, and just check the records. Also, we have a metrics and the tracing endpoint. Those are mostly for troubleshooting purposes. Definitely don't use the metrics endpoint in production. I am saying this because I have heard that people are using it in prod. Use the Micrometer support for the backend of your choice. Cool. Health endpoint. Let's dive a little bit deeper into this, because this can be interesting. So here, the health endpoint can say that, hey, your service is up, and this is why it is up, or this is why it is down. That can be more interesting. And you can see that there is one component here, which is a database. The database is up. It's an H2 database. And the interesting thing is that in order to have this, I did not do anything. I just told Spring Data JPA that, hey, this is my database URL. And Spring Boot was smart enough to auto-configure a health indicator for me automatically. Also, you can get a disk space indicator out of the box. If you have seen disk is full errors in your logs or anywhere, that happens. This can alert you before that happening. It has a threshold. It can say that, hey, you are very close. You might want to do something. Also, the ping one, it will always say up, which is good for example, like a Kubernetes, like a liveness probe. But two things I implemented is HTTP service indicators, because I am using some HTTP client. But those services are also Spring Boot services with the Actuator endpoint. So I did nothing, just told the HTTP service that, hey, call the health endpoint of the other services, and based on that, report the same thing back. And this is my favorite Actuator endpoint, the info endpoint. However, this endpoint is empty by default. But you can use this to fill it up with a lot of very interesting and important details. For example, this is out of the box supported. You just need to add a few things to your build system and turn them on. You can see your build details. For example, you can see that, hey, this build was made for this commit, or based on this commit, and that branch, and that commit happened that time. Have you ever deployed a wrong version into production? This can save you. Or you might deploy the right version, but the right version was made based on the wrong commit. I have seen that happening a lot of time. Also, it can tell you the details of the build. Hey, this is the build artifact. The build was made at this time, and this is your version number. My version number is gibberish, but you can see the real version number of your build system. So you can see that there because I am versioning this build by commit id.timestamp. But you can do whatever versioning you want. This will be there. This is new. I implemented it in Spring Boot 2.6. So you can know now what Java version are you using. And I have a neat story for this. I believe I will tell you later, if you remind me at the end, if you will have some time. But this can also save the day. The environment active profiles, that can also be nice. I haven't implemented it, so you do need to do it on your own, but it's very easy to implement such a thing in Spring Boot. You just need to implement an interface called info contributor, create a bean for it, and you are done. And the interface is very simple. You just get a builder that you can attach things to it. You are basically building up an object, and that's all. So active profiles can be pretty neat if you, for example, have multiple environments or multiple profiles, and you want to know if you are about to start or you started a service with a production profile in staging environment. That's not good. Also, these are not implemented either, but hopefully they will come soon, as I will have time to implement them. But you can put memory and CPU as well here. And the interesting thing here is that, hey, I already know this. My host, I know how many memory and CPU do I have. But this is the memory and CPU what the JVM is aware of. And that can be different. For example, if you are running in a cloud, in a containerized environment, this can be different. So for example, if you set the Docker CPU limit to 2, and the JVM thinks it's 16, or if you set your memory limit of Docker to, 2 gigs, and your JVM will think it is 64, that can have bad consequences. For example, did you know that if you don't set the CPU request in Kubernetes, then what Kubernetes will pass to Docker as CPU shares, the JVM will read that value, and it will calculate this available processor count, which will be 1. And if that happens, then it will mean that you will have the serial GC, which is single-threaded, you will have 1 JIT threads, and also there is a thing in the JVM called common pool. The size of it will be 1. And the common pool is used in parallel streams. So your parallel streams will not be parallel because you have 1 thread. It is also used in the fork join API. So if you are using it, it will not be parallel. Or if you are using something which is using the fork join API, for example, completable future, that will not be parallel either. If you are running in Kubernetes, check if you are setting the CPU request and limits, because you can bump into these things and it can bite you. Also, the memory can get you into trouble as well, because what can happen is that, let's say that you have a host and that host has 64 gigs of RAM. So previous Java versions, this was backported in 8, but there is a update, I don't know which one, on top of my head, but if you're using an older like Java 8, what can happen is that it did not have support for Docker or containers. So it will see the RAM of the host, which can be interesting because out of the box, the JVM will size the max heap based on this amount. So if the JVM is seeing that, hey, I have 64 gigs, but your Docker limit is 2 gigs, and it will size the max heap to, I guess, 16, in case of, I believe it's the quarter of it. That will say that you will get into OOM killed by Docker if your heap is growing. Also, you can add details like the garbage collector that is used. That can be useful too. You can put there hey, what is the time zone that the JVM is using, the operating system, which version. This detail, by the way, the operating system, it is coming in boot 2.7, so it will be the next release in a month. Network details, the heartbeat, which is basically the current timestamp. If you ever had clock skew issues, which are happening all the time, that can help you to identify that. And there are other things that you can put there. For example, how to contact the dev team, or where is the repo of the project? How can I get support? What is the email alias? And so on. Also, if you're running in a cloud environment, you can put things there like, hey, what is my instance ID, my instance type, which account, which region am I running in? If you are on HTTPS, you can put there the subject and the issuer, so that you can you can see if you have or why you have trustor issues. You can also put the expiry date on it. In every year, there is a huge Fortune 100 company who goes down because of this, because an expired TLS certificate. You can prevent it. You can just say, hey, I am putting a health check indicator on top, and I am going to check that. You don't need to bring your service down if your TLS expiry date is 1 month from now, but definitely you can have a red blinking light going on so that you can fix it. Also, you can create your own endpoints. For example, you can put all of the dependencies that are used runtime. If you still remember Log4j, and if you ask the question, okay, which Log4j version am I using? This can be extremely useful. Or if you're using some security framework, let's say Spring Security, you can put a who am I endpoint there, so that you can see that, hey, you use this principal, or this is your username, and this is the roles that you have. Okay. Last part. So you can also have a service registry, and you can implement service discoverability, which I think these fall to the observability umbrella. You can answer questions like how many instances do I have, where they are, which versions, by which environment, and so on. One of the solutions for those is Eureka. If you are using Kubernetes, you sort of have something similar. If you're not, Eureka is a service registry. It will basically just keep the record of your services. And another thing that you can have is Spring Boot Admin. Spring Boot Admin is basically, it is also a service registry in itself, but you can point it to Eureka if you want, and it can show you like the list of services, what versions do you have, and so on. And more, what it can do, it can provide you a nice UI on top of the Actuator endpoint. So you don't necessarily need to look at the JSON if you don't want to. You can have a UI like this. Also, we have a project called Tanzu Application Live View, which is pretty similar to this. It is also integrated with Kubernetes. You can see the registry of your services, and it can also provide you a nice UI for these Actuator endpoints. And there is API discoverability, which I think this is like equally important. So with this, what you can do, there are a bunch of things that you can do here. One of them is generating documentation. So for example, Spring REST docs, it can generate docs for you from tests and from handwritten docs as well. Also, you can use Spring Cloud Contract and the packet broker. And what they do, they are implementing consumer-driven contracts. And what consumer-driven contracts does is basically it will test your client-server contract. So when you make a change in your code base and you are making a breaking change for your clients, or like in the API, or you are making a non-breaking change for the API but a breaking change in the behavior, you can run tests that were defined by your clients against you. And this can be an awesome thing. If you have clients, look at this one. This is pretty neat. Also, you can use things like Swagger or OpenAPI and Redoc to generate an API specification and also documentation. So what they do, they are scanning your controllers that you created, and they will generate you the docs based on those controllers. And they are discoverable. You can browse your API, and they also contain an HTTP client. So you can just browse like which are the APIs that you can use, and you just press a button, and it will call your service, and you will see the response. Also, there is Spring HATEOAS, which stands for, bear with me, Hypertext as the engine of the application state, and Hell Explorer. And what this does is for REST calls, for REST resources, it will add links to your resources. So you can have a resource, and that resource can also tell you a bunch of other things that, hey, these are the other resources I am pointing to. For example, if you have a book resource, and that book resource can contain authors, every single author resource can have a link to the how to query the author resource, like /authors/ID, which you don't need to follow. You don't need to make this whole thing up. I will show an example for that. Also, the Hell Explorer is also an API browser and a client. So this is Swagger UI. It's like lets you browse your APIs, and also like if you expand it, there will be the client that can call your service. And this is an example for HATEOAS. So what you can see here is on the top section, which is basically the ID, and the others, I did not put those there because of space. That is your resource. And the rest of the, sorry, that was an unintended pun. So the other parts of that resource, that REST resource, is the links. And the links section can tell you, hey, this is how can you query this resource, or how can you search it, or how can you delete it, or this is the resource for the collection if you want all of these resources. And you can do this not just for one resource, but for like multiple ones. So if you look at this response, this is a response from a paginated API. And you can see the tea leaves there. That is your array. That contains your resources, your REST resources. And the bottom section will tell you the details about the pagination. So you can see that we have 5, the page size is 5. The total elements is 15. That's why we have 3 pages. And also we are on page number 1. And it is like 0 indexed. So we are on page 2. And the links section can basically give you some very, very nice navigation view. So you can see that the self link points to page 1. And we have a previous and the next link. And you can also have a link for the first and the last element in the collection. If you have ever like implemented like a iteration logic through a paginated REST API, this can like simplify things a lot. You don't need to do the math. You don't need to like calculate, hey, if this is my page number and the page size is this one, then plus this, oh, I am one of, there is a problem. You just need to follow these things. So you just do next, 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 until there is next. If there is no more next, then you're done. So HATEOAS can be very, very useful there. If you want to increase developer productivity, please implement these. And I believe that's the end of my talk. If you have questions, please feel free to ask those, because if you ask questions, I have swags for you. I have like spring socks. I don't know. Have you seen the Spring 1 keynote in 2021 September? You did. That was about a service called Spring Socks. So you can get socks, you can get pins, and I have a couple of stickers as well. Just go ahead.
The one which you showed, the Informator, which shows the Git branch details,
Yep.
version details, and all that. Is there something newly added, or is there?
No, that is there for a while. You can go to the documentation of Spring Boot and go to the info endpoint, and you will see that. What you need to do basically is adding a plugin to your Maven or Gradle project, which will generate a property file based on your build, because Gradle and Maven know those details. So they will put those details into a property file, and when boot starts, it will get that property file, it will be built into your jar, and it will read it and show it to or on that endpoint.
But the Micrometer is going to be part of Spring Boot 3?
Spring Boot 3 will come with Micrometer, yes. Right now, Boot 2 is coming with Micrometer. Boot 3 will too. Yes. So it's not just like Micrometer Core, which is like for metrics, but Micrometer Core, Micrometer Tracing, and so on. So multiple things will come there.